So I'm still doing section 4.7, optimization problems. There's just two more. I wanted to make this a separate video. Okay. Number 4 is kind of difficult. So we're talking about find the area of the largest rectangle that can be inscribed in a semicircle of radius r. Problem, there's no numbers. This is all going to be in terms of variables. So this gets a little messy. Okay. Anytime I want to maximize or minimize a rectangle square that's inscribed, I want to center it at the origin. Okay, so if I draw this out, I have what? Find the area of the largest rectangle that can be inscribed, that means inside of a semicircle of radius r. So I'm going to draw my rectangle so it's centered at the origin, and I'm going to draw my semicircle like that. So there's a rectangle that is what? Inscribed in a semicircle. Okay. Now, why I did that is this point I can call xy. Okay. And if I connect these, that's the radius of the circle. It just helps me to create what I need to do this. Okay. So find the area of the largest rectangle. So area of the largest rectangle is what? So if this is xy, this would be x, this would be y. The area of that would be 2x times y. So the equation that I'm trying to what? Maximize is 2xy based on how I drew it. The other equation I have is I can just use Pythagorean Theorem. I know that x squared plus y squared equals r squared. Okay. Why do I need that? Because this is asking me in a semicircle of radius r, so it wants it in terms of my radius. Okay, so I can now solve this, say for y, and I would get the square root of r squared minus x squared. Simple, just solve for y. Now I could come over to my area and I have 2x times the square root of r squared minus x squared. Okay, so now what? R is my constant. I have to look at R as a constant, not a variable. Okay, so R is some number. How do I know that? Because it's saying in a semicircle of radius R. So X and Y are my variables. R is a constant. That's why I solve this for Y. So now I only have one variable here, and R is like a number. R is saying of any size R. Okay, so now I can go and find the derivative of this. And what you're really doing is you're solving, x would be your critical numbers, but x is going to be in terms of r, because r is like a constant. So this is a constant. All right, so now go ahead, do the same thing. So a prime, go ahead, find the derivative of this. So it would be 2 times the square root of r squared minus x squared. Product rule with the two things I underlined, guys. Okay. What? Plus, 2x times 1/2 r squared minus x squared to the negative 1/2, okay, times derivative of this, which would be negative 2x. Clean this up a little bit. So this would be minus, okay, and what? This would cancel with this. I'd have 2x squared in the numerator over the square root of r squared minus x squared. Now I need to set this equal to 0 and solve. You're solving for x in terms of r. Okay, so how would you do this? How would I solve this for 0? Okay, two things. One, you could multiply everything by this denominator. Okay, or you could add this over and cross multiply. It's really doing the same thing. Okay, so if I multiply everything by this denominator, I'd have what? 2 times r squared minus x squared. Okay, so if I multiply this whole equation by the square root of r squared minus x squared. First term minus, these would cancel. I would just get 2x squared equals 0. Okay, so I'd have what? 2r squared minus 2x squared minus 2x squared equals 0. So I would have 2r squared minus 4x squared equals 0, and now solve that for x in terms of r. You should get plus or minus r over square root of 2. Okay? So if I solve this for x, that's what I get. So find the area of the largest rectangle that can be inscribed. So that's my what? That's your x value. So now I would have to actually find the area when I put in r over root 2. So now I'd go to area here, and I'd put in r over root 2, and I'd simplify it, and you should get r squared. Okay? So weird with all variables, or all letters technically. X is a variable, r was actually a number in that problem. Okay? And then the last problem we did last year. Go ahead and read it. See if you remember. You can go ahead and try to set the equation up. So how large a rebate should the store offer to maximize its revenue? So what's revenue going to equal? If I sell 200 Blu-rays, I make 350 each. Okay, so this is the number of Blu-rays. This is the cost. If you multiply how many you sell and how much you're selling it for, you're going to get how much money. Now, for every, $10 rebate, so every time I take $10 off, I'm adding 20 more I sell. X stands for how many times you offer that. So 1 rebate, 5 rebates, how many times you're going to take $10 off. Okay, now what do? Create a quadratic. This is pretty simple now. Once you have the equation, FOIL that together. And then what? So last year, how do you find the maximum of a parabola? You find the vertex. Now we're saying what? Find the derivative and set it equal to 0. So if you go ahead and find the derivative of this, we get what? Negative 400x plus 5,000. Okay. Set it equal to 0, and you get 12.5. Now go back, answer the question, how large a rebate should the store offer? So what that's saying is what? I should take $10 off 12.5 times. So if you actually go and put 12.5 here, you actually get what you should sell them for. And if you put 12.5 here, you'll get how many you'll actually sell. Okay, so the price should be $225. Okay, so this is kind of cool. We did this last year. Last year you just found the vertex of this. Now we're actually using the vertex of your original. Now we are doing the derivative and setting the derivative equal to 0. You're finding the same thing. Think about it. Here's the parabola. If you find that x value by doing negative b over 2a, you get the x value. If you find where the derivative is 0, you're getting that same x value. So it's 2 ways to find the maximum of a parabola.